Hi guys, and welcome to Magic. My name is Thomas Hansen and I'm one of the magicians over at servergardens.com, and in this video I'm going to show you some of the threading features of Magic. As we're all painfully aware of, multi-threading is possibly one of the most complex tasks you can do when it comes to software development. However, in Hyperlambda I've significantly simplified the threading model to the point where it can arguably be easily understood by even a junior developer. Now, if you want to reproduce everything I'm doing in this video, you're going to need version 9.8.0. As you can see here, that release was just recently released, some few minutes before I created this YouTube video. Then go to the Eval menu item, and at this point, let's create a thread. For character return tab, http.get colon, and then https //servergardens.com. Now this obviously creates a thread. And as we can see now, even though, and in fact, let me just detab this thing and mark only line number 4 and hold down function and click F5 on my Mac. If you're on Windows, you can just click F5. At which point you see the request takes a lot of time. Let me show it once more and watch up here in the top parts of my page. So you can see invoking this thing takes, a second. And in fact, let's create more of these guys. Let's copy it and do gaiasol.com. Let's copy it again and do dzone.com. And if I now detab the thing and I execute all of these 3 guys, then obviously it will take even more time, right? You can see the wait icon up here. It spends a lot of time executing. So one of the advantages by threads is that you can basically create a thread that you fire and forget. And that is basically what I'm doing here with the fork keyword. Notice now, returns instantly. Why? Because this workload is actually occurring on a different thread. So if you now go down and see here, we don't even have a result because this code is actually executed on a separate thread. So it might not finish before 2-3 seconds after the Hyperlambda evaluator actually returns. And we can continue doing this to invoke these in parallel. Now I'm creating one thread for each HTTP GET invocation. And of course the result is the same, more or less. As you can see, it immediately returns. Now when I click execute here, it takes 0.1 second and the thing returns, because it is executing on a separate thread. This allows me to do, for instance, blog.info :x : / content. And then I can do the same for this guy and this guy, right? And if I now open up my log, then some, 2-3 seconds later, you will see that it's logged my content. Here you can see it's logged the first one. Let's see if there are more of these guys. Why aren't there more of these guys? Log info. Doesn't matter. The point is now, what I can do if I want to. At this point, I can actually join my threads, which basically implies that execution down here will not pass down to the next line of code before all of my threads are done. And in fact, let's prove that by doing log.info all threads are done, and then let's execute it. Now you see we'll actually wait for each of these threads to finish their work. And if we look at the result now, all of a sudden I actually have access to the results for each of my threads here. If you see the third one, for instance, down here, you will see that all of the results from all of my 3 threads are actually available for me to manipulate at this point in time. So let's do log.info thread 1 finished, thread 2 finished, thread 3 finished, and then let's execute it. Then let's refresh our log. And as you can see here, thread 1, thread 2 finished first, then thread 3 finished, and then thread 1 finished, and then it logged all threads are done. So it basically waits for all of my threads to be done before it moves past my join invocation down to line 12, where it logs all threads are done. This allows me to create multiple pieces of workload that are actually executed in parallel, while yet still wait for all of my workloads to finish before execution is done. And in fact, due to the fact of that Hyperlambda is inheritingly and implicitly asynchronous in nature, this actually means that while my HTTP GET invocation here is actually waiting for network traffic to be returned from https://servergardens.com, the thread will be suspended, released back to the operating system, and available for next thread or next piece of logic that happens to need a thread. The same will occur with this one, the same will occur with this one. So when we are down here and we're actually waiting for all of the above threads to actually finish, then before network traffic is available from the network card to the HTTP GET slots, my piece of Hyperlambda is actually consuming 0 threads on my server, which is crucial, especially for applications that requires insane amounts of scalability in regards to throughput, which implies that it's highly unlikely that my web API backend ever at any point of time is going to be exhausted of threads and returning 502 or 503, I can't really entirely remember, what the operating system returns or the web server returns once the thread pool is exhausted. So this arguably takes a ridiculously complex ID, multi-threading, async, forks, joins, wait statements, etc., and makes it ridiculously easy to understand. And it's just like implicitly there. And of course, for the record, all of my fork invocations are actually fully fledged Lambda objects. And so is my join. If I want to do down here, log.info, logging from join, and then I execute. Now you'll see something interesting. Once the threads return, if I refresh my cache, you will see 6 seconds ago, logging from join, done, thread 1 finished, thread 2 finished, thread 3 finished, all threads are done. Why? Because my join slot here is actually just a Lambda object, and I can do whiles and for each and whatever, for each, blah blah, inside of my join. Anyways, that was it for today's video. Thank you for watching, and there's a link in the description of this YouTube video from where you can download Magic. Yet again, thank you for watching. Have a nice day.